Hello, my name is Daniel and I'll go through my balls game I've made for 3D graphics programming and physics for computer graphics. Upon starting, we get introduced with this page. We can press M to start game, and we can then use one of those controls displayed here to basically control the game. For example, we have I for straight throws, O for curved, and we can decrease and increase the power by using minus and plus. And when we're ready, we can press space to throw the ball. So for example, let's set the power to like 8. We can select I and we can throw the ball, and that was actually a pretty decent throw. We can press R to restart and we can try different throws. Now we can have a go at a curved throw. Let's select left and we get something like this. We can press R again to restart and try a different throw. Of course, we can now, let's have a look at decrease the power and we can try and a right throw, something like that. And then we have different type of cameras which we can have a look at what's happening here. And we can use this to plan our next throw. And finally, if you happen to throw the ball at too much power, you'll actually land in a ditch and will be forced to reset and try again using different powers. In this video, I'll go through the graphical aspects of the game. Now onto the technical stuff. In modern OpenGL, we do things slightly different than we did in Legacy. For example, we will be creating VAOs and VBOs, an array of them, and we'll be binding vertices into them. We will be binding our objects into these arrays, which we can then call and draw. For example, here we will be working with these field vertices, which is where the ball is rolling and everything. We're binding all these vertices, all this information into the VAOs and the VBOs. Once we binded those information into the array, we can start working with the images and the textures. The way we do textures, it's very similar to Legacy. We'll grab a texture array and then the image. Here we have the image as the grass. We'll bind the grass into texture 0, and we use the technique called repeat, which is basically something like this. We will repeat the image over and over again to create this better look. Basically, we will be repeating it 10 times, since we put here 10. We'll be repeating 10 images for each direction, and we will be binding that image, that texture, into a location, which will go through shaders, and here we binded that location to 0, and they will go in order as we create more and more objects. And finally, once we binded the VAO and the texture, we simply refer to the location. The location starts from 0, the VO starts from 0, they refer to our shader. We will define more objects as we create more of them, and they will have to match the ones in shader. Then we will do the VO0 because we binded all the vertices information into VAO0, and then we will bind the texture into this VAO and then draw it. Going back to the game, what I've also included is its model loading. As you can see around here, we have benches, and there in the background we have a house. But here we have a really good example of one of the models I've done. It's a cube with proper textures on them, unlike the other ones, because I had trouble with the other ones. But because this is a simple cube, the model, the textures are all mapped properly. I will go into details of how I made this cube and the textures. So here's our simple model of the cube, and essentially what we do, when we export it as an OBJ, it will save each individual vertex and vertices and the points, and the program will then take that OBJ file, which is a text. It will go by each line, and connect all of those. This is how an OBJ file looks inside a Word document. And basically the program, the loader I included in my game, will take each individual line and connect them. So here are the points of them for the faces, and we got for the materials as well. But in order to get the materials working, we will have to make cuts in our model to lay it down flat on a piece of paper. So we'll make a cut like this. The least cuts possible to lay it down on a paper flat. A cut here, and we will make another 2 cuts right here. This will allow us to lay down this model flat on a piece of paper, for example. This is how it would look like. After that, basically, once we have this laid out, and basically by unwrapping it, we will provide the OBJ the coordinates of where we want to apply the textures. Then what we would do is simply imagine we will put a texture on like this, and we will wrap it all around. And that's what happens in the program. It will wrap it. It will connect all the vertices together to create the I'll go through how I draw the sphere now. Basically, we have multiple of slices which we can define in our program, which will adjust. The sphere will adjust to the value as we change it. That go from the top of the sphere to the bottom. We also have radius that gradually decreases from the middle of it, around it. It will decrease and go to the top, and decrease and go to the bottom. Along with that, we have vertices. Vertices are in the intersection of the slice and the radius. And we have stacks that go around the sphere. With this information, we can find out the position of the vertices, and the vertices are in the intersection with the slices and the stacks as well. And here on the left, we have the UV mapping, UV coordinates of this. This is more for textures, but we can use this as an example of how we draw it. Basically, this all wraps around and makes a sphere. Here's the function for drawing the spheres. Simply put, it's working through how many stacks we define, how many slices we define, including the radius. And basically from the bottom we draw individual face, firstly gradually increasing with the radius and then decreasing once it reaches the half point. And it draws individual face around till it finishes the sphere. Now onto the lights. Lights are simple. Firstly, we define where we want the light positioned, and then we will get all this information and pass it onto shader, the shaders we have. So we will pass all these type of lights, the ambient, diffuse and specular, into our light 0, which is defined in our fragment shader. Here is how our fragment shader looks. We define the lights, the material, which we can change in each individual bowl to make them look different. And we then calculate the dot product. We grab the light direction we defined, we times it by the diffuse color and the ball material, which we can change in each individual ball, and then we basically output it as a texture which we can use when we draw the ball. This is how diffuse works. We basically shoot the light into the objects and it casts out rays of lights. And we can change the color if we prefer to have a different color. And this is how the shadows and lights look like. In conclusion, I'm really happy with the game turned out. I'm happy that the shadows are working properly. I'm happy that all the textures are looking very nice, and just the balls all look very good. And I'm overall happy. The only problem I have is with the benches I've drawn using the model loader. Opposed to the cube, which is an easy shape and has only 36 vertices, the bench has about 30,000, which is probably the cause of it not getting drawn properly, as you can see. Same with the house. There should be a door and everything, but that's the only problem I had. But other than that, I'm really happy with the game. and thank you for watching.